scientific notation with small numbers. Remember, numbers less than 1 are considered small, and if we have small numbers, we have negative exponents. So in number 1, we want to change this to scientific notation, so we want our first number to be between 1 and 10. So I want to move my decimal point to be after the 4. So our beginning number was less than 10, so I moved it 3 places to go from here, 1, 2, 3, and therefore my exponent is negative 3. In number 2, I'm going to move it 2 places, so I'll take 5 times 10 to the negative 2. In number 3, it's like, wow, it's really, really, really long, so we want it to be after the 8, so 8.411. And then you've got to count from here to here, and I believe if I counted correctly that that should be negative 20 because there are 19 zeros, and then the 8 makes it 20. Now in number 4, there's 2 different ways you can think about number 4. The first one is thousandths. We know that thousand means 3, so you could say, well, thousandths means it's to the right of the decimal place, and that would make it negative. That's one way you can think about it. If that's a lot of thought, well, 8 thousandths, hopefully you know place value means there are 3 decimals, and the 8 comes at the end. So that would be 8 thousandths. Then you could say, well, I need to move it 1, 2, 3 places, and that would give you your answer of 8 times 10 to the negative 3rd. Either way, that works. Now in number 5, we have 96 million. Well, million, that's a big number. So 96, 1, 2, 3, 4, 5, 6, and my answer, right, I want my decimal to be between the 9 and the 6. It starts at the end, 1, 2, 3, 4, 5, 6, 7. So I have 9.6 times 10 to the 7th, right? Thrown in a positive one just to keep you on your toes. In number 6, we want it to be between the 4 and the 1. So 4.1 times 10 to the, it's small, so it's going to be negative, 1, 2, 3, 4, 5, 6, and we have 10 to the negative 6th. Again, in number 7, we have a big number, so 9.345, it's going to be a positive exponent, 3, 6, 9, times 10 to the 9th. And in number 8, 6/10. Well, 6/10 is the first place past the decimal, so if I move it, I'm moving it 1 place, it'll be 6 times 10 to the negative 1st. And now let's go the other way. So let's take scientific notation and go to standard form. So this little arrow caret thing means it's raised to, so that implies that this is like 10 to the negative 6th power. I just typed it so it'd be a little bit easier to read. So when I have a negative 6, that means my decimal is going to go to the left 6 places because it's getting smaller. So I'm going to have 1, 2, 3, 4, 5, 6, because this 7 will have to be one of the places. So I would go 1, 2, 3, 4, 5, 6, and fill in with zeros. So in number 2, I'm moving it 2 places to the left, 1, 2, so you can see that there's only a spot for 1, 0. So if you start in scientific notation, you will have 1 less 0 than what the exponent is. So like in number 1, we had a 6, and we ended up with 5 zeros. In the second one, we had a 2, we ended up with 1 0. So in number 3, we have a 1, so we will have no zeros. We just move it 1 place to the left, and we've got 0.93. You'll notice in number 4, our exponent is positive. That means we are going to have a big number. So we move it to the right, 15,921. Number 5, we're moving it to the left 3 places because it's negative. So I will have 2 zeros, and then the number. Positive, moving it right, 2 places. Negative, I'm going to move it left 9 places, so I will have 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 4, 3, 8. And in number 8, I'm going to move it left 5 places, so I'll have 4 zeros. 1, 2, 3, 4, and then 3, 5, 4, 9, 9, 3, 2. We want to keep all of those numbers because they are given to us. And the next one. So now we're going to do some actual math. Okay, and it does say write your answer in scientific notation and standard form. So first of all, I'm going to write this vertically. So 8 times 10 to the 2nd divided by 1.6 times 10 to the 6th. So first, right, I'm going to divide my numbers. 8 divided by 1.6 gives me 5 times 10 to the, when I do my exponents, remember if I divide, I subtract. So 2 minus 6 gives me negative 4. So there's scientific notation because my first number is between 1 and 10. And then if I want to change this to standard, I've got to move my decimal 4 places to the left. So 1, 2, 3, 4. Remember, if it's got a negative 4, that means I'll only have 3 zeros. Let's multiply. 2.14 times 3.7 will give me 7.918. And if I multiply, I will add my exponents. So negative 4 plus 7 is 3. Scientific notation. To go standard, I'm going to move it 3 places to the right because it's positive, and my answer is 7,918. Number 3 is already written for us in this form, so I will divide in vertical form. Divide 5.88 divided by 3.2, and that is 1.8375. And then if I subtract my exponents, I'm going to take 2 minus negative 5. So 2 negatives is a positive, and my exponent should be 7. And to go to standard form, I'm going to go 7 places to the right. So 1, 2, 3, 4, 5, 6, 7. Throw in some commas, and there's my standard form. And last but not least, number 4, we are multiplying. So again, I multiply my straight up numbers, 4.06 times 2.17, and I get 8.8102. And because I'm multiplying, I add my exponents, which would give me negative 3. Negative 7 plus 4 is negative 3. So there's my scientific notation. And now to go standard, negative exponents, I'm going to go left. Negative 3 means I have 2 zeros, 88102, and there's my standard form. So scientific notation with small numbers.